Hi guys, welcome back. I hope everybody's doing great today. What we're going to learn about today is arcs and angle measures of intersecting chords, secants, and tangents when they intersect with a circle. So first one we're going to do is interior intersection. So it says, if two secants or chords intersect inside of a circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. So if you want to know the measure of angle 1, the intercepted arc is AD and BC. And remember, these two angles are the same because they're vertical angles. So if I add arc BC plus arc AD, because those are its intercepted arcs, and I divide by 2, I get the measure of angle 1. So that's the formula over here. And then if I want angle 2, I take the measure of arc AB and the measure of arc DC, and I add them together, divide by 2, I get this angle measure. And remember, these are the same because they're vertical angles. So that's how you go about doing these. So we're going to do a couple of examples together. So in this one, it says find the measure of angle AED. So we're looking for this angle. So notice the intercepted arcs are this arc and this arc, because when you have your secants are the ones that intersect your circle twice. Those are the arcs that are formed. So in order to find the measure of angle AED, you take both of those two arcs, so 45 plus 109, add them together, and then you divide by 2. So if you're going to do this all in one step, just make sure that you put parentheses around that in your calculator. And then I would get that this is 154 divided by 2. And then I would get that it's 77 degrees. So the measure of that angle is 77 degrees. Awesome. 2 is the same, so we're going to skip that one. Okay, this one wants to know the measure of angle YWX. So it wants this angle. Now notice we weren't given those intercepted arcs. We were giving the intercepted arcs to find this angle. So let's find the blue angle first. So to find blue angle, we're going to do 81 plus 43, and then we're going to divide by 2. So that would be 124 divided by 2, which ends up being 62 degrees. So this is 62. And then notice that this is on a straight line. So that means this red angle would be whatever makes it add up to 180 degrees. So to find the red angle, I'm going to do 180 minus 62, and I will get that that is 118 degrees. So the measure of angle YWX is equal to 118 degrees. So sometimes you'll have to remember supplementary, but remember the intercepted arcs give you the angle that is in between each of those intercepted arcs. Awesome. Number 4 wants us to find the measure of arc LK over here. So what you have to do is you realize, okay, so you have the 2 intercepted arcs and you know this angle, but you're looking for whatever this is. So let's label that X. So it's set up the same way. I know if I do 74 plus X, your 2 intercepted arcs, and divide by 2, I'm going to get 62. So the first step I'm going to do is I'm going to multiply both sides by 2, so I get rid of 2 in the denominator here. So then I will get 74 plus X, oops, that's a weird plus, is equal to 124, 62 times 2. And then I'm just going to subtract 74 from both sides, and I'll get X is equal to 50. So that means the measure of LK is equal to 50 degrees. Okay, so same formula, just working backwards a little bit. Okay, we're going to skip 5, and then we're going to do 6. So 6 wants us to find the measure of arc QT. All right, so in this one, the 2 intercepted arcs would be these 2 guys, and then the angle would actually be this angle. So you're going to reverse it here, and you're going to figure out what angle that red angle would be to make it supplementary. So I would do this angle is equal to 180 minus 79, which is 101 degrees. So this is 101. And then you just have to set up the formula again. So you know, let's label this X again. You know that 95 plus X divided by 2, your 2 intercepted arcs, so this plus this divided by 2 should equal 101. And then you're just going to solve for X. So start multiplying both sides by 2 to get 95 plus X is equal to 202. And then subtract 95, so you get X is 107. So that is your measure of angle, or of arc QT, is 107 degrees. So that's where you guys stop. Okay, so remember, these were 2 secants intersecting on the inside of a circle. Those are the formulas that you use. Next one is what happens if a secant and a tangent intersect at the point of tangency. Then the measure of each angle formed is equal to half the measure of its intercepted arc. So you've got your secant AB here, and then you've got the tangent, and they're intersecting at the point of tangency, so where that line is tangent to the circle. So what that means is that this measure of angle 1 right here is equal to half of the arc AB. Measure 1 is equal to half the measure of arc AB. And same with measure 2, this whole angle right here is equal to half of this entire big arc of ACB. All right, so let's do a couple examples. So in this one, they want us to find DEG. So we're looking for this whole angle right here. And we do see that we have this whole arc is 308. So in order to get the measure of angle DEG, we just take the whole entire arc, the 308, and we divide by 2. So if I take 308 and I divide by 2, then I'm going to get this to be 154 degrees. So that means the measure of angle DEG is equal to 154 degrees. It's as easy as that. Okay, in this one they want DBC, so we're looking for this angle. Now they didn't give us that arc, but they did give us this arc. So I can go backwards and then we can use the fact that all the angles on this line add up to 180 degrees. So if this arc is 192, I can get the blue angle down here by doing 192 divided by 2. And I'll get that's 96 degrees. So that means this angle inside of here is 96. So then to get my red angle, I do 180 minus 96, which is 84. So the measure of angle DBC is equal to 84 degrees. Pretty easy once you realize it. Okay, this one wants the measure of arc XY. So they give us this inside angle. So then we can find the measure of this arc by doubling it. So the big arc is going to be 2 times 151. And so that becomes, I guess there's actually probably an easier way to do this. Let's back up. So we know that this whole line adds up to 180 degrees. So if this is 151, I can actually find this angle by subtracting it from 180. So if I do 180 minus 151, we get 29. So that means that angle is 29. And then the arc is just double that. So the measure of arc XY is going to be double that angle 29. So then it's going to equal 58 degrees. It probably works the other way if I was going to go and reverse it all, but that way it's a little easier. Okay, so that's your secant and your tangent when they intersect at the tangent point. And now here's when you have exterior intersections. So it says if a secant and or tangent intersect on the exterior of a circle, then the measure of the angle formed is equal to half the difference of the intersected arc. So here's the 3 examples you guys have. So this one is when you have 2 secants, so 2 lines that intersect the circle twice. The big arc, this arc CE minus the arc BD divided by 2 gives you the angle outside of here. So they're intersecting outside of the circle. So this arc minus this arc divided by 2 gives you the angle formed outside the circle. Same thing with secant and tangent. So you have a secant goes through the circle twice and a tangent touches once. It's the big arc minus the small arc divided by 2 gives you this measure of angle A right here. And then even if there's 2 tangents, you still will take the big arc minus the small arc divided by 2 and you'll get this angle A. So that's your process for all of these when they're intersecting outside instead of inside of the circle. Okay, so this one wants us to find this angle KLM right here. So seriously, it's as easy as doing big angle, or big arc 140 minus small arc, which is 66, divided by 2. So 140 minus 66 is equal to 74. And then 74 divided by 2 is equal to 37 degrees. So the measure of angle KLM is 37 degrees. Awesome. Angle ABC. Okay, so this one's a little bit neater because we don't have this arc right here, but we can figure it out. So you can see that this arc is 88 and this arc is 62. So the rest of that is just what gets it to be a full circle. So if I do 360 minus 88 minus 62, I get 210. So this arc is 210 degrees, and then I just plug it in my formula. So I'll do, 210 minus 62, so minus this arc, divided by 2 is going to equal the measure of angle B. So 210 minus 62 is 148, divided by 2 ends up being, what, 74? So your measure of angle B, or ABC, is 74 degrees. Awesome. Okay, this one, notice we've done 3 examples so far actually. So we've done the secant because you have 2 lines that are intersecting your circle. This one was a secant and a tangent, and now this last one right here is going to be 2 tangents because they only intersect the circle once, but it doesn't change. You have your big arc is 313, In order to get the small arc, you're just going to take 360 minus 313, and you'll get that that small arc is 47 degrees. And then you just plug it in your formula. So big arc minus small arc divided by 2 should equal the angle on the outside, which is this PQR. So 313 minus 47 is 266. Divide that by 2, that should be 133. So your angle outside right here is equal to 133 degrees. Awesome, just a couple more examples here on how this can differ a little bit. So the next one we're gonna do is you have two secants again, and they want us to find the measure of BCD, angle BCD, so this angle right here. Okay, so let's see, we have the big arc is 67, and we need to find the measure of this arc. So notice that this is going through the center of the circle. That means that this is a semicircle. So that means that all of this has to add up to 180 degrees. So if this is 67 and this is 94, this is whatever makes it be a 180. So I'm just gonna do 180 minus 67 minus 94, and we'll get that that is 19 degrees. This little arc right here is 19, and then we just use our formula. 67 minus 19 divided by 2 is 48 divided by 2, which is 24. The measure of angle BCD is 24 degrees. Okay, 3 more. 14, we want to find the measure of arc SW. Okay, so this one we're going to have to set up. We have everything we need. We have the two arcs, big arc, the small arc, and then we do have this angle. So let's just write the formula that we know. So we'll call this arc SWX. So I know if I do x minus 75 divided by 2, I know I get that outside angle, which is 40. So now you're just going to do some algebra and solve. So multiply both sides by 2. So you'll get x minus 75 is equal to, what is that, 80? Add 75 to both sides. So x is going to be 155 degrees, and then x was our arc SW. So our arc SW right here is equal to 155 degrees. So just doing the formula and working backwards. All right, this one wants us to find the measure of arc MK, so the inside one here. Okay, so same thing. Guess we'll just call this one Y. How about that? So you take big arc, so 160, minus small arc, which is Y in this case, divided by 2. We know that's going to equal 56. So then do some algebra. First thing you do is multiply both sides by 2. So you'll get 160 minus Y is equal to 112. Subtract 160 from both sides. So then you get negative Y is equal to negative 48. Multiply both sides by a -1 or divide by -1, whatever. We'll get Y is 48. So that means your measure of arc MK is 48 degrees. Okay, last one. And you guys are going to do some practice. Let's see, we want to find arc EF. So we're looking for this one in the end of it. Okay, so we can find this one because we have the big arc, the purple arc would be our small arc, and then we do have this angle. So if we did, let's just call this X, and we'll call this one Y. So let's do 191 minus X, big arc minus small arc, divided by 2 should equal our 77. So multiply both sides by 2. So we'll get 191 minus X is equal to 154. Subtract 191. So we'll get negative X equals negative 37. So then X is 37. And then that means this arc is 37. Now we know that to get this red arc, it's just what gets it to be a full circle. So to get this arc EF, I'm just going to do 360 minus 191 minus 37, and I'll get that that's 132. So the measure of arc EF is 132 degrees. So again, not too bad. It's just remembering the formulas and knowing when to use which one. So hopefully at this point, you guys have all of these formulas written down. If they're intersecting outside, you take big arc minus small arc divided by 2. If they are intersecting with a tangent and the secant on the circle, the arc is double this angle, or the angle is half of the arc. And then the last one is when they intersect on the inside, it's the two arcs added together, divided by 2 will give you the inside angle. What you guys are going to go do now is go do some practice on this. Make sure you reach out and ask for any help if you need any. And I hope everybody's having a great day. Bye, guys.